Hey, I'm Ashmed. I built Logmate, a full stack ELD trip planner for truck drivers. So, this entire FMCSA log sheet and trip schedule was generated automatically from our route simulation using HOS constraints. So, let me show you how it works. Let's go to whiteboard, and here's the problem statement. So, the interesting problem here isn't route planning. That part is easy. It's that a single trip might require pausing mid-leg for a 30-minute break, restarting the entire 8-day cycle, or splitting a sleeper period across two calendar pages, all while generating legally valid driver logs. So truck drivers in US operates under HOS regulations. So this means that the system has to simultaneously track driving limits. They have to track duty windows, mandatory breaks, off-duty requirements, and rolling cycle limits. And once the driver reaches 70 on duty hours, the system has to automatically insert a 34-hour restart before planning can continue. So, so the scheduling logic becomes more like a constraint simulation problem than normal route planning. Okay, enough said. Let me generate a trip. Let's go to logmate.smithyagi.com, and this is how initially it looks like. We need to enter current location, pickup location, drop off, and initially how many hours a driver has used in his cycle. So let's enter Chicago. Okay, we are getting suggestions. St. Louis and Dallas. And so, so I'll set the driver to 65 cycle hours. So they only have 5 hours remaining before the cycle limits force a restart. Okay, so I'll enter 65 and we click on plan trip and we'll wait for results. And there is it. There it is. 971 miles. Drive time is 17 hours and 45 minutes spread across 4 days. Right. So we are also getting this warning banner, so this warning banner is important. So the scheduler detected that the driver runs out of cycle hours during the trip. That means mid-trip. So it automatically inserts the required 34-hour restart. And the route visualization updates along the generated schedule, right? We can see. But the interesting part is the generated logs. So these are fully rendered as SVGs on the front ends. So day one is where the cycle exhaustion actually happens. So the driver starts normally with a pre-trip. Let me zoom it a bit. With a pre-trip duty time and driving. But after using the remaining cycle hours, which were 5 out of 70, 65 were already used, 5 were remaining. So after using the remaining cycle hours, the scheduler automatically forces the restart of 34 hours. So the rest of the day for day one becomes the sleeper birth time, which starts at 11 on day one and ends at 9 on day two, which calculates up to 34 hours. So then, near the end of day two, the driver resumes activity with pickup handling and short driving segments. With pickup, now we have day three. So day three is the main driving day. After the restart completes, the driver gets a fresh cycle window. So it becomes the largest driving segment of the trip. So we can actually see all the duty transitions here. We have day four. Day four wraps up the trip. The Now let's try the edge cases. Let's go with when driver already has 70 hours used using the trip before the trip even starts. So let's enter 70. click on plan trip. So here scheduler shouldn't even attempt driving first. It should immediately insert the 34-hour restart. Yeah, as we can see, it immediately insert the 34-hour restart and only then plans the trip forward on day second, right? Which is exactly what should happen. Now let's quickly get an overview of architecture. Okay. So this is simple bird eye view of the architecture front. Then we have level two component breakdown, and this is our backend infra. Our backend is hosted on DigitalOcean. So yeah, Nginx is there, Guernica. Now let's have some code walkthrough. We'll start with hoscalculator.py. .py file. So what this file contains is the actual HOS scheduling engine. This scheduler basically behaves like a state machine. It continuously tracks cycling hours, driving time, break timers, duty windows, current locations, and accumulated trip mileage. Okay, and so most of the scheduling logic happens inside this loop. So for every iteration, the scheduler calculates how far the driver can continue before hitting a constraint. So that could be anything. That could be fuel requirements, brake timing, the 11-hour driving gap, the 14-hour duty window, midnight rollover, or it could be the 70-hour cycle limit. As we can see, the logic is defined over here. What it does after that, then it takes the nearest constraint, advance the simulation forward, and insert the appropriate duty event and continues again. Okay, all the logic is defined over here, over here. So this section handles the 34 hours restart logic. And one more thing to make sure the scheduler stays correct as I iterate on it, there's there's a PyTest suite covering each FMCSA rule. And over here we have written some test cases. We have tested. Yeah, I think that's about it. So this is hosted on logsmate.asmitagi.com and source code is available on GitHub as well. Here, this is our source code. And one thing I've been experimenting with recently is maintaining structured documentation. Yep. Designed not just for humans but for AI agents too. So this LLM wiki is a new concept coined by Andrew Karapathy. So this wiki folder follows a more organized reference structure for that workflow. Yeah, that's Logmate. Thank you.